Tonight, yet another major tech company is unveiling new advancements in quantum computing technology.
That's right. This time, Amazon revealing its first quantum chip. The processor is called Ocelot, and it promises to be better at making complex computations with fewer errors compared to other companies' chips.
The news follows announcements of breakthroughs from Google and Microsoft. These companies producing these chips that can make calculations that wouldn't be possible, even if we combine the power of every normal computer in the world. Think about that for a second. The chips promise to solve generational problems for society. That's a lot of pressure. As we hear more about advancements in quantum computing, many may have questions about how exactly this works.
All right, so let's try to break this down for you. A normal computer chip is able to make calculations using bits, which can be turned off and on like a light switch. Now, we normally see this represented with ones and zeros, what we know as binary. 0 means the bit is switched off. 1 means the bit is switched on. And it's very easy for us to know which state these switches are in.
Meanwhile, quantum computers use quantum bits or qubits. Qubits, they take advantage of a quantum property known as superposition. Oh, that brings to mind dark matter. This means the switch that can technically exist as on and off at the same time until we look at it. And there's always a certain probability it will be one or the other.
50-50. All right, so this is where things get kind of cool. Quantum computers also use another property called entanglement. Now, if we had two qubits that were entangled, we can change the state of one just by looking at the other. For example, if we look at our first qubit and it's in the on position, we know if this qubit is on, the other will be off. And if we look again and the first qubit is off, the other will be on. So just by looking at the first qubit, the other changed.
So this theoretically would allow us to find out the other qubit's state instantly from anywhere, even across the universe. Einstein famously referred to this concept as spooky action at a distance. And it's the basis of these theories around the so-called multiverse, as I just referenced, right? Dark matter that deals with superposition and all the multiverses you could have access to. It's why quantum computers are exceptionally stronger than even the most powerful classic computers.
All right, so does this mean we'll be living in the world of science fiction anytime soon? Not necessarily.
Yeah, it also doesn't mean we'll be carrying quantum computers around in our pockets in the near future. In order for these quantum computers to be used, they need to be cooled to basically absolute zero. Right now, the coldest temperatures in the universe are right here on Earth, inside giant tubes that house quantum computers. Now, because even the tiniest change in temperatures can switch these qubits on and off without us controlling them.
So what can we use these quantum computers for? That's the big question. It will soon be able to use, you can use it to make AI much faster and better, improve batteries, and even figure out how to make more effective medicines.
Yeah, but we're still always looking for ways of achieving these dreams, of course, and most quantum chips right now have a few dozen qubits available to use.
So scientists say in order to get practical use out of these quantum computers, we need a chip with 1 million qubits. All this, that visual really helped, though,
it did.
With the switch.
Yeah, and I'm still stuck on superposition just because, like I said, that is in a show, but it helps you kind of visualize what a multiverse might look like.
Yeah, those movies always confuse me.
Interesting
It's
stuff. It's like Tenet almost, you know what I mean?
Thank you, exactly.
We're on the same page. Still ahead, questions mount over whether Medicare recipients will